Good morning. My name is Kenichi Goto from Toyo University in Japan. Today, I would like to present our study on implementing peer assessment in introductory chemistry laboratory courses, focusing on its educational impact and student perceptions. First, I would like to describe the background of this study. Many first-year university students experience a significant gap between high school preparation and university-level expectations, particularly in laboratory report writing. As shown here, 77% of students reported anxiety about writing chemistry laboratory reports at the university level. The bar graph illustrates students' prior experimental experience in high school, showing large variation across subjects. This uneven background contributes to uncertainty and anxiety when students are required to write full scientific reports. Based on this background, the purpose of this study is to examine how peer assessment can support both cognitive and affective development. Specifically, we focused on three core objectives: improving students' understanding of report structure, enhancing their self-assessment ability, and reducing anxiety related to report writing. This triangular relationship highlights that learning outcomes are not only cognitive but also emotional and metacognitive. The theoretical foundation of this study is the concept of assessment as learning, proposed by Earle. In this framework, assessment is not merely a tool for evaluation but a process through which learners regulate and advance their own learning. As shown in this circular diagram, students move through cycles of self-assessment, peer assessment, and re-self-assessment. Through this repeated process, learners gradually develop deeper understanding and greater autonomy. This study involved 43 first-year students from the Department of Food and Environmental Sciences. All participants were enrolled in an introductory chemistry laboratory course. The experimental scope included 6 laboratory topics, ranging from basic analytical chemistry, such as acid-base titration, to applied experiments like ethanol production and aspirin synthesis. These experiments required students to write full laboratory reports throughout the semester. Peer assessment was conducted using a 5-level rubric covering 5 evaluation pillars: purpose, method, results, discussion, and scientific expression. Students evaluated both their own reports and those of their peers using this rubric. The rubric provided a shared framework, helping students clarify expectations and recognize strengths and weaknesses in scientific writing. This slide outlines the overall procedure of the assessment cycle. After orientation and laboratory sessions, students conducted self-assessment followed by anonymous peer assessment. Feedback was then provided, and students reflected on the comments before revising their reports. Instructor moderation and questionnaires were incorporated to ensure reliability and to collect research data. Next, I will present the quantitative results. We observed significant improvements in students' understanding of report structure. Scores for both what to write and how to write increased significantly from session 1 to session 6. These results indicate that repeated peer assessment contributed to clearer structural understanding of laboratory reports. We also examined changes in assessment behavior. Students reported that both self-assessment and evaluating others became easier over time. This suggests that repeated practice reduced the perceived difficulty of assessment and increased students' confidence in judging scientific work. In addition to cognitive outcomes, we observed notable affective changes. Confidence showed strong correlations with both report grades and understanding. Furthermore, enjoyment of self-assessment increased significantly. These findings suggest that peer assessment positively influenced students' emotional engagement with learning. We also observed changes in students' vocabulary. Initially, students used general expressions such as smooth or careful. Later, they increasingly adopted scientific terminology, including structural formulas, causality, and literature comparison. This linguistic shift reflects growing disciplinary identity. We also observe changes in students' vocabulary. Initially, students used general expressions such as smooth or careful. Later, they increasingly adopted scientific terminology, including structural formulas, causality, and literature comparison. This linguistic shift reflects growing disciplinary identity. Based on these findings, we propose a 5-stage growth model. Students progress from formal understanding to technical skill acquisition, scientific thinking, autonomous learning, and finally a researcher-like attitude. Peer assessment appears to support movement across these stages. Overall, peer assessment produced several educational benefits. Students used peer reports as learning resources, improved their metacognitive awareness, and experienced reduced anxiety. These outcomes suggest that peer assessment functions as more than an evaluation tool, it becomes a learning resource. However, several challenges were identified. These include ambiguity in evaluation criteria, leniency and acquaintance bias, and difficulty transferring peers' strengths into one's own writing. Additionally, peer assessment alone was insufficient to build self-efficacy for some students. In conclusion, peer assessment functions as a sustainable mechanism for ongoing learning in introductory chemistry laboratories. It promotes structural understanding, reduces anxiety, and enhances self-assessment skills. Future improvements include clearer rubrics, stronger anonymity, scaffolding for transfer skills, and additional support for self-efficacy. Thank you.